Hey guys, welcome back. Today I'm recording this knowing that this is sort of an experimental process for me. But I have three of this model, the P102, and I have one of this larger model, the P104, that I removed all the cells from. Three of them were damaged and the cells were no good at all, and one of these smaller packs, the 102s, the cells, I was able to revive them and they functioned, but their capacity was so low that it was basically useless. You couldn't really use it for more than a few seconds on something just because the capacity was so low. So the cells that were still useful, I saved them out of this. Pull them out here. So I have all of these, is that on camera? All of these green wrappered ones here came out of these Ryobi packs. And these are all, a couple of these are 1.2 amp hours in what they have for capacity left. The rest of them are 900 to 1,000 milliamp hours. And then I got a bunch that were totally bad that I held onto for practicing because I got a spot welder here. This is a Seesii spot, I think that's how you say it, Seesii, not sure. This spot welder was reviewed by some folks online that said it worked pretty good, and it's an all-in-one rechargeable solution, which sounded very convenient to me. I've bought ones once before that you hook a lead acid battery up to it, like a car battery, and I didn't have good luck with getting that to work reliably, so I don't have that anymore. But this one, I just did some practicing on some, if you don't know, if you take empty cells or bad cells, drain them down to absolutely no voltage. This is 100% empty. And then you can use it for, I don't know if you can see that on camera, there's a whole bunch of divots on there. So I was practicing on some of these, doing welds, ripping them off, doing welds, ripping them off, and getting a feel for how everything works. So my plan is I'm going to order some good quality, high current cells, brand new, online. If you shop around, you want to make sure you've got ones that are rated to deliver really high current. These cells that came out of the Ryobi batteries, these particular ones, these are not the only kinds of cells they use. These are LG cells that are rated for 15 amps of continuous draw. And I know firsthand from making my own wall adapters to power tools, that plenty of these tools will hit over 350 watts, especially in the peak startup current. And that's 15, 16 amps, which is a lot of beans. So for at least the regular, I haven't checked out the insides of any of the like HP batteries, the high performance ones. Makes sense to me that those probably have higher maximums, but in these regular ones anyway, in all these regular ones that I've seen so far, they've got 15 amp rated cells in them. So that's what I'm going to be ordering brand new, so I can rebuild these and have them be good as new. Those are about $3. Well, it's like $2 to $3 per cell, plus the shipping adds a bunch on there, and you've got to order, enough to make it worth it. Because if you're spending $20 on shipping to order 2 cells, then obviously the per cell price is kind of awful. So I was looking, and I think the price for the ones I picked out is going to be about $3.50 per cell when you factor in the shipping for the quantity I'm going to order. But before I go through all that, I really wanted to, I've got some of these older cells. These are recovered from something else. I don't even remember what. These are all just shy of 3 amp hour cells. I don't suspect that they're good for as many amps as they ought to be for this, but I know these are all good cells, and they're all relatively similar in capacity. And so I'm going to install them in one of these, kind of as a test to practice doing it and see how this process goes. And then when I go order the new batteries, I will go through the effort to rebuild all the packs with all fresh high current batteries. So I didn't put all the screws back in this when I put it away, just because it was unnecessary. So just for convenience, I've got it here. And we've got, so this one uses this particular model. There's a few different models, like internal configurations that I've seen so far. These ones, these older P102s, these use this kind of cage setup. This guy, I believe, has got like silicone rubber like liners that are in separate pieces. So there's a few different internal configurations depending on which model battery you've got. Ooh, that is sticking. So if you get this where when you're taking one of these apart, if it's a little sticky, you don't want to pull on this too hard because it's just held on with some soldered wires, and we don't want to accidentally rip anything. But if you push down on the metal contact there, you can push everything out. So for this, I'm going to put all the screws and everything aside. We don't need this right now. All we need, oh actually, I lied. We do need the 2 screws that go into this cage. This cage comes apart. So it's in 2 pieces, and in both of these locations a screw goes down in there to hold the cage together around the cells. When I took this apart, I made a point to mark the overall negative and the overall positive so I could make sure everything went back in the correct way. You can also tell, which way this goes around by the circuit board. So there's mounting holes on the circuit board that line up with these mounting holes here. So if it's all put together correctly, then you can trace out, figure out which side's supposed to be positive and which side's supposed to be negative. So we don't need the brains right away. We'll get to that. What we need right away is to take our batteries and load them into this cage. And so these have been soldered on, or soldered on, depending on how you want to pronounce it. These have had solder applied to them in the past, which for low current stuff is fine. Depending on who you ask, it's probably fine for high current stuff as well. There is a risk of doing that you cause damage to the cell by overheating it. But honestly, if you're being relatively quick about it and getting the job done rapidly, what you want is a nice hot soldering iron so that you can go in there, melt things rapidly, and get out of there. And there's flux around here. It probably looks like rust on camera, but that's like flux residue and gunk. But again, this is really for a practice session more than anything to make sure everything works. Probably I won't leave these in here when I'm done. I'll replace them with the new batteries of the new cells when I get those. But that is, so, for, what is this, 5, 10, 15. So this is going to take 25 cells to rebuild all 4 packs. Right, these smaller ones, like what I'm holding here, these have 5 cells in them. But this thicker one actually has 2 sets of 5 in there, so that's 10 in that one. So I will probably replace these when I get the high current rated cells, because I don't honestly know what the rating is on these. But again, I just want to prove that everything works the way I think it does while I'm practicing, because those buying that many cells and shipping them, it's going to be like almost $100 for me, US, which is not a small number. And so I want to make sure I'm not practicing on the expensive stuff, frankly. But I'm also have had these cells, just pushing everything together, had these cells just spare in my bin there for quite a while. Alright, so the way this should be laid out, you have the overall negative for the pack on one end, and you'll put the negative side of that cell over there, and this negative and positive will alternate so that it zigzags across until the last positive is over here. So you want to make sure they're alternating. Make sure you have the first one in the correct orientation, and then just alternate after that. So I'm going to install these screws that hold everything together. These on this cage are T8 security bits. Are they security screws, or are they just regular T8s? These are just regular T8s, it looks like. Okay, so we're done with that. That's the only T8s on this that I need to worry about. So, orient this the right way. So let's get an idea of what we're going to do here. So, the way this works, I'm just going to set this stuff aside for later. Alright, so the way this works, you'll have one big connection. You can see the remnants of what I cut off here. One big connection that goes to the overall negative, and one relatively big connection that goes to the overall positive. And that's because when the battery's being used to power a tool, all the energy that you're pulling out of the battery comes across these large contacts here. These other contacts in between, these are relatively thin wires, and these are just for voltage monitoring of the individual cells. So these don't really carry any current to speak of. They're just for sensing. So these are much less, they don't have to be so beefy. They're much less critical. The way this will work, I've got some zinc here. That's what these tabs are made out of, is zinc. Sometimes if you get the really cheap stuff, it might be like zinc plated steel sometimes. But usually what you want is all zinc. So the way this will work, you'll have the overall negative. I'm just going to try to visualize this for you so it makes sense. I'll try to do this concisely because I tend to ramble. The overall negative will come right off these brains, bend over, and go straight onto the overall negative cell. And the positive on the other end will do that same thing. And then all these cells in between, you connect them end to end by going across like this. So the overall negative comes across, clips over to the next one, and that goes across. That will go onto the one next to it. Same thing, goes across, comes back, goes across, and then the overall positive will be by itself, just like the negative. So what I'm going to do is start with getting the pairs laid out. And we'll weld those on. And then we can weld in the overalls. Probably need to grab my soldering iron or warm up my soldering iron to undo. You can see I cut the old zinc strips, and they're still kind of just got little bits stuck on there with the solder. But we can do that in a moment. Let's grab, where are my snips? Alright, so I'm going to measure out what I need for zinc strips and just kind of pre-cut the stuff I need. So I'm going to take this. I'm not sure if this is okay to charge at the same time as using it, so I'm going to unplug that. We're going to give this some power. And we've got these leads that we will connect here. Those are rugged. Alright, so these are the welding leads. I don't know if you probably can't tell so clearly on camera, but this is all insulated here. There's a see-through insulation on that coming down till, so just this little tip here is exposed. So I'm going to start my soldering iron warming up. So that's ready for after this step. Alright, sorry, I had to pause for a second there and go get some more water for the cleaning sponge on my soldering iron. If you don't know, you can get these little water bottles in like the garden section of like Lowe's or Home Depot or wherever. Probably smaller shops too, I don't know. But it's only a couple dollars, and it gives you this bent nose, and when you squeeze the bottle, I'm going to try to do this so you can see it. You squeeze the bottle, it squirts out. So it makes it really easy to wet your soldering sponge without getting water everywhere. Super convenient. Love that thing. Alright, so that's our overall negative. I'm just double checking where I was at. Keep these from touching each other. We don't want that to short. Is everything in frame? Looks like it. Alright, so I'm just going to dive in. Gonna just kind of push these into position so that they're kind of making decent contact and about where I want them to be. Ooh, that looks a little... Yeah, I like that better. So on the positive side, maybe I should talk about that. So on a cell, we can actually go ahead and just peel this off so I can show you this anatomy a little bit real quick. In case you don't know. If you do know, fast forward a minute or two because it's going to be boring. Let me peel this off. So this is the negative side of the battery, and this whole cylinder, this whole can is all one piece with that negative. So this whole thing's all negative, all the way up to the tippy top, all negative. The positive part, it's probably going to be difficult to see on camera. I'll try. So you've got, this is the positive side, and if you can see that very thin sort of gasket in there, it's a little bit like a brownish creamish color on this one. That's the insulation between negative and positive. So all the metal you see outside of that gasket, all this on this lip here and all the way down, this is all negative. And this inner circle, this inner raised circle, is the positive. So when you are doing this, you don't want to get this, if you've got that insulative wrap on there still. Let's grab another one. So here's an empty one, right? You don't want to accidentally slide this up underneath that wrapping because you could easily short the battery, which would be very quickly bad. So you want to make sure when you put this on, show you on this, when you put this on, you're not accidentally kind of stabbing the corners into there. You want to be up above the insulation so you don't risk shorting out on that. And that's what these circles, these are little, usually plastic or sometimes they're wax paper type material. They put that on first and the insulative wrap goes around it, which is just like shrink wrap basically. And that helps give you a definite, hard edge to where that insulation ends, so it covers all the important bits. And you can buy packs of these rings online, or if you have a 3D printer, you could even just print really thin little rings on your 3D printer, as long as you've got that kind of accuracy for your bed leveling. That's what I was making sure of a moment ago. Again, because all the negative side is, this whole side is all negative, you don't have so much to worry about on that side. So I'm just lining this up to make sure it's in a position that I'm happy with. And I'm just kind of pushing it on there to kind of form it a little bit over the plastic of the cage. And then we're going to get started. The reason, by the way, I may have already said this, I'm not even sure now. The reason spot welding is preferred for cells is twofold. Number one, is it's very easy to automate with machinery, relatively, versus soldering or soldering. Either way, you know what I mean. However, and also it imparts much less heat into the cells that you're connecting. Not no heat, but way less. Like these are cool to the touch. Well, that's slightly warm, but these are cool to the touch in just a couple seconds. There's not that much to worry about as far as temperature goes. And so that's why it's preferred. If you're not doing something, that's particularly high current or needs such thick connections, because you can imagine this this strip is a lot of surface area because of its width relative to if you had a thin little wire. I can feel these heating up a little bit on this. Maybe I should slow down. You know what I can do? I can change the delay on this to force me to slow down. Is it this button? Yeah. I'm going to increase that delay. I was on 2.5 seconds. I'm going to make it 5 seconds, which will just force me to go slower. Make sure that that temperature is totally, that heat, a little bit of heat's dissipating well between welds. Brilliant. I dig it. So now we're going to flip this over and do the same thing on this side. This is the, make sure I've got my orientation. This is the overall negative on right here now. So now we're going to do these guys over these two locations. So make sure those don't touch. And I'm going to do the same thing, just kind of press these into place and have them, see, that corner is trying to get up under there, and I don't want that. There we go. Yeah, it's very soft and easy to kind of shape the strips, the zinc strips. So the way this welder works, it's got settings over here where you can control, they call it gears from 1 to 8. So it's, and it goes in 0.1 increments, so it's like 70 settings or something like that. And I'm actually using it on the highest setting. After testing on some of these bad cells, I needed to be like at least gear 6.5 so that the welds were strong enough for me not to be able to just pull apart with my hands. And after trying many settings, I decided for this that I was just going to go with gear 8, and it seems okay. Again, you know, having a handful, you can buy like practice cells online on websites where that's just an empty, like an 18650 with no guts, so you can practice on it. But just take any old 18650 you have and just run its voltage down to 0. Just put a resistor across it or something, and run it flat. Run it totally flat, and then you can feel really totally safe to just practice away and totally mess it up and figure out what your settings should be and make sure you get it right. And so other than the gear setting, there's a delay setting. So when it's got circuitry in there that detects when these two tips get shorted together through by touching the strip at the same time, and the delay setting tells it how long to wait before it fires the welding pulse after it detects that. So I've just upped it. Let's see, it goes 0.5 from half a second up to 5 seconds, looks like the maximum. And I think I'm just going to leave it on the maximum of 5 seconds because it kind of forces a little cooldown in between welds when I'm doing these in a row. And yeah, this is my my first day using this welder. I bought it just recently. I did a bunch of practicing, not a bunch of practicing, but what felt like enough before I started to record this. And I'm really pleased with it. You know, my first impression of it is it's doing the job. It was easy. It's easy. You know, I don't have to sit here and play with too much to try to get it to work right. It's USB-C rechargeable, and it also works as a power bank. You can hook up to the USB-A port here and drain out of it. I don't know off the top of my head if the C port can charge out also, or if it's input only. But I'm really pleased with that, and it gives you, you know, a temperature reading, a battery capacity reading, and it's real easy to use. So I'm pleased with it so far. My first impression is very positive. All right, so we've got these series connections here. All that's left is the overall connections. So I'm going to take out, we're going to need to get the, let's see how this lines up. Need to get the overall PCB on here. Oh, you know what I'm doing? I'm doing it backwards. So we need to get this PCB mounted. And I think what I'm gonna do, in order to make this be as straightforward as possible, what I think I'm gonna do is actually, instead of trying to trim the strips that I have down to the exact size. So the way this works coming through the circuit board here is that whole strip is just bent up like a tab through there and just flooded with solder to get tons of connection, strong connection on there. And I don't know, oh, what I have might actually be an okay thickness to go up in there. But I think what I'm going to do instead is just weld onto this tab for now and bend it over to go onto the cell. So it doesn't need to be, so I don't need to resolder up there. And this one, you can see, this has a great big wire coming down. This one would not be as annoying to replace the whole strip. But for purposes of wasting as little of my supply of stuff as possible during this practice test, which I know, or pretty sure I know, that I'm not going to leave hooked up forever. It's just temporary. I'm not gonna worry about that yet. I will definitely film it when I do the final version of all this, and you guys will get to see that. But for this, for purposes of practicing this and letting you guys see me practicing it, I'm just going to run with it as is. So we've got a couple screws in here to pull out that hold that PCB in place. Put that aside again. So put that aside. Now you do want to be very careful once you've started making connections. accidentally shorting stuff on here becomes even more of a thing that you need to worry about. Shorting one cell is bad, but once you've got stuff connected, you could cause a short that's at a much higher voltage potential. So you definitely want to be extra careful doing this stuff as he drops a screw on the PCB. It's also a good idea not to have your cells fully charged when you do this. I've got these cells at a storage voltage right now of about 3.6 or 3.7 volts each. Just because the less amount of energy they have in them, should something go horribly wrong, the better. Alright, so that's in place, and also just keep in mind you're screwing into plastic, so be careful you don't strip those screws or those holes. So on here, you see we've got these lead wires, right? And then also this little black wire that looks sort of like a teardrop at the end, that's actually a temperature sensor. So by default, normally that temperature sensor is stuck with these pads onto the side here, and that, something like that, and that helps monitor the temperature of the pack, because in addition to monitoring the voltage that the PCB does, you also want to monitor the temperature, because an over temperature situation could be really problematic. That can cause stuff. So I'm turning off the welder. I'm done with that for the moment. I'll need that again in a minute. I'm just going to set this aside out of the way somewhere, because the next thing I want to do is get these soldering connections figured out. So what I'm going to do is, might want that to help. So the first thing I want to do is get, maybe I should have done this off camera. I'll fast forward through this a little bit. I'm just going to use my soldering iron to get these little bits of the old stuff off. Okay. That was only slightly annoying because the wires were pushed in through a little hole on there, and then folded over and then soldered. So a little bit of wiggling to get all those out. Toss these scraps away so I don't accidentally short on them or something silly. Alright, so the next thing to do then, I'm going to put a little puddle in the middle of each one of these. Oh gosh, look at the accident that almost made. Little ball of solder had fallen on that. Alright, so note to self, a little more care next time. So what I'm going to do is just get a little puddle of solder on here. So I've got something to connect that wire to. Is that going to reach okay? Yeah, it's barely going to reach. Maybe next time I will add like a little section off of the maybe next time I'll put the effort in to add a little flap on these, actually, because you can some people, you can take this and you can bend it over, so like you can literally bend it over like that, or you can also take like a very short section and you can weld a little flap on top of the spot, on top of the part you already welded. So you can do that if needed, to add stuff on there. And again, I'm really just trying to be cheap. with this practice one. So there's a couple of little plastic guides to help hold these wires in place, and I'm just feeding that through. That's kind of bulky. Let's grab some tweezers. Where's my tweezers? Let's grab some tweezers. Alrighty dighty. So now I'm just gonna melt that onto that puddle. And just hold that until it's cooled all the way. Do the same thing here. Just want to try to hold that without wiggling while that solder cools and solidifies. And that looks super fine for me. Again, too, these sense wires, basically nothing is flowing. Ooh, well, that barely reaches. That doesn't, in fact, that doesn't reach. So I might have to do something different with that. And that doesn't really reach either. So these wires are a little shorter than I want them to be. See, you can see before this was connected to a flap that went up there. So that actually doesn't quite fit. So I'm actually going to go ahead and put a little elevation flap on these, because apparently it would benefit from having that. So we will cut off 2 short little pieces. And we will, I guess I'll pull the welder back out for this. Make sure those are separate. Power this bad boy on. Start it up in the same settings I had it on before. And so I'm just going to, whoop. This might, doing this on here might melt that little piece of plastic that's behind it, but actually we'll turn this down to 6.5. Whoop. There we are, 6.5, because this is going to be a lot less stuff behind it, like, you know, it doesn't have all the thermal mass of the whole casing behind it, so we're going to do that. Just do 2 on this one. Nice. Again, this thing being just for sense, it's way less currents going through this. It's not going to be anything obnoxious. I'm just going to push to kind of shape that in. Yeah, that's actually, I went down to 6.5, and that even feels a little bit too strong. So I'm going to drop it down to, what I say, 5. Yeah, that feels fine on 5. Yeah, I'm happy with that. Probably I could have even gone a little bit lower if I wanted to. So I'm just going to, the way I'm doing this, I'm just pushing this so it kind of bends over the top. Let's turn this off. Put that out of the way for now. We will use that again in just a moment. So let's take this. How do I want to do this? I wish I had like a something I could prop this at an angle, but whatever. We'll make the best of it. We are going to put a puddle up here. There's that. And puddle up here, same thing. And you could even like I said before, you could solder these on, if you know you were going to do this, you could solder these onto these first before you welded them, and then weld them after the fact if you're worried about the heat getting into the cells. Yeah, see, got all that space for activities. Whoop. That joint looks a little yucky, but that's okay. Not the most beautiful solder job I've ever done. Okay. So next, right, we're going to be making the final connections onto the circuit. So let's try really hard not to screw that up. Let me think, what do I want to do here? Do I want to, how is that done? Oh, that looks like it's crimped over the wire too. Alright, so let's take a section of this about like that. We're going to go yoink. And then how big do we want on this side? We're going to go about like that. Yoink. And these I'm going to double up. Because again, the overall positive and the overall negative connections, those are going to be transferring all the current for the whole pack through them. And they're a little bit longer than the other connections. So I want to make sure there's very low resistance there. So we'll do this negative first, I guess. So how do I want to do this? We're learning together, you guys. Yeah, I'm going to do it just like that. All right. Whoops, almost dropped it. Turn that on. I'm going to go back up to the higher gear for this right here. We're going to do a couple connections here. Very pleased with that. So up here on top, I'm going to gear this all the way down to 4 because I'm just going onto this other strip. There's not so much mass behind that again. Does that seem okay? Maybe I'll go up to 5. Alright, and then we're just going to go directly over that again with another strip just to increase the total carrying capacity of this connection. Went up to gear 6 on this now. Yeah, that looks pretty good to me. And then back up to 8 on this side. Brilliant. I'm happy with that. All right. now this, and now this. So I'm just gonna try to push this into a position where I'm happy. Maybe I'm going to, that little kind of remnant of the connection that's there is a little bit floppy. So I'm going to just get this started over here first. And I can bend that over. Take a look at that, where that's located. Yeah. Turn that down a bit. Make sure we're going to be making a nice solid connection here. Make sure that's lying nice and flat against it, so we're making good contact. Okay. And then we're going to put another one on top just for extra capacity here. I'm not positive that it's necessary, but it certainly won't hurt anything to have more than you need as far as carrying capacity. And again, since these cells are, as far as I know, not really rated for anything crazy, they're probably not going to be able to put out enough to matter anyway. Cool. Alright, turn this off. Set you aside. Alright. Feel it. I'm just feeling for any heat. See if anything's going poorly without me realizing it. This little thermistor here, it's got a little guide here for that wire to come down here. So we are gonna take this pad and put you back in place. A little piece of foam was over that to begin with. See if we got that staying in there. Alright. Let's pull our meter out. Is there glare on that, or can you see that okay? No, that's glary. Oh, that's a little better right there. So we are, let's check our output. Look at that, 18.4 volts on the output. 3.6, hold on. 3.69, 3.7, 3.75, 3.7, 3.84. So they're pretty close to balance to begin with. That appears to have worked just fine. So I'm going to, do I want to reassemble this? No. You know what I'm going to do? I think I'm going to balance these cells first. Let me think. Nah, I'm not going to balance them. I'm going to leave them in their partial charge state. if this thing seems like it may actually be capable of being left with these cells and actually still be useful for something, then I'll rebalance them. I'll balance them perfectly. They're not too far off anyway. Was it 3.69 to 3.84, I think was the range. So basically, it's really close to balancing. That's good enough for this. So let's reassemble it, and then we'll see if it works. And if it looks like it's going to, and then I'll also test what kind of current it's happy putting out. I have a rig that I can test that with. Let's see, put some of these things back away so I can find them when I'm looking for them. We don't need the Phillips bit anymore. We just need this T10. So again, you're screwing into plastic posts, so especially if you're taking things on and off a few times during a test of a battery pack, make sure you're being careful about not stripping stuff. All right, let's test a thing. Let's start with we'll start with something super gentle, just a flashlight. Look at that. So at the very least, the battery is functioning. Let's test something that takes a little more juice. That does not sound happy with that current. Oh, maybe it's the gear I'm in. No, it's not the gear I'm in. That does not sound like it's delivering enough current to be useful for something. Let's hook this up. Keep in mind, it's only at about half charge, but we can still test it. So let's take this. So what I've got here, this is just a battery shell that has an XT60 connector that just goes straight to the outputs. And with this, you can hook up an exterior power supply. So like I've got a 300 watt or 330 watt power supply, like a wall adapter. So I can plug this into a tool and I can power it from the wall. If I don't need to be portable, I can just run a cable. But what this will let me do, we can connect the battery just like this, and then we can take our clamp meter and we can see, let's see, we want DC current. I'm going to wrap this on there. We're going to zero it. Is that on screen? Yeah, it looks on screen. So when I pull this trigger, we should see on here an idea of how much current it's providing. And I don't know if you saw that, but that briefly peaks at like 7 amps at the very start and drops to about 3.5 amps of continuous, which is not enough. These cells are not putting out anywhere near enough to be useful in a real tool. But the experiment did work, and it is functioning. If I were going to dedicate it to just something like a flashlight, it would be totally fine. Those would run this flashlight for many, many hours. Those cells, by the way, were 3 amp hour cells, or 2900 milliamp hours, I think is what they measured at. So my drawer's sticking. So those cells, those were just shy of 3 amp hours each. They were like 20. They measured at like 2,900 milliamp hours. So if I wanted to dedicate this pack to being just like a flashlight only pack or something like that, I could do that. Put like a big warning on this so I don't try to put it in something else, because it wouldn't do very well if I was maxing out the amperage on those cells the whole time. Yeah, but it clearly works. So definitely need to buy the higher capacity cells. I'm sorry, not the higher capacity, the higher amperage cells, so that this is going to be useful. But yeah, the whole process works. This was a successful test. 100% happy with that result. Yeah, so I have, again, I think I said it earlier, but these original Ryobi cells that were in these packs are rated for 15 amps continuous. So I'm going to replace them with some cells that are rated for that from a reputable source. And yeah, and then we will do another video at some point in the future when I get that order in, and we'll reassemble these other packs. And then these will be the ones that I looked at. I think they were 2,500 milliamp hours. So that would make this would make this a 2.5 amp hour pack when it gets those new cells. And the one that'll have the double stack, that'll be a 5 amp hour pack with those cells. Yeah, cells that are in series, you add their voltage together. And cells that are in parallel, you add their capacity together. So when you have the 2,500 milliamp hour cells all in series, then the total pack is still just 2,500 milliamp hours, but at the higher voltage. When you add a second one of those in parallel with it, for the bigger shell, when you add the second row, then that second row in parallel doubles the capacity and keeps the voltage the same. So that's how that works. All right. Thanks for watching. I hope you learned something. I'm really pleased with the performance of that welder. I think this thing was, I want to say, somewhere around $50 on Amazon. I think if you are willing to wait for shipping, you can get it cheaper than that on like AliExpress, like 35-ish US, I think when I looked. But yeah, I'm really pleased with this. So just a real quick update. I measured the current draw of this flashlight, and it's only 160 milliamps, which is very, very low current and well within the wheelhouse of these low performance cells. So I'm actually going to keep these in here, I've decided, and just have this cheap, cheapy pack dedicated to flashlight use, so I can have this thing ready to go, power outage or whatever. And yeah, so I'm gonna call that a total win. I'm gonna think that that's useful to have on hand, because these are low current cells. I'm also only using a very low current charger. In case you didn't know, these little chargers, which I'm very fond of because slow charging is better for your battery longevity than fast charging if you don't need it. These are only 6-watt chargers, which is very low. These guys, these bigger boys, these are 60-watt chargers, so 10 times the speed. But if you don't need that speed for something, then it's just harsher on your batteries for no reason. So I've got a few of these slow chargers that I normally use, and I pretty much never use this unless I'm doing a project and I need to recharge the batteries quickly and have them ready to go right away. And then there are even faster than that chargers that Ryobi sells. I think their fastest one is 90 watts, I want to say, for the 18 volt stuff. So yeah, so I'll make sure I only charge it gently and only use it in some of these gentle applications, and I don't have to have expensive cells dedicated to something like this, and I'm happy with that. I bet these would also be great in the small fans that Ryobi has, or maybe the Bluetooth speakers. I bet those would be good uses for these low current cells too. So yeah, if you are rebuilding stuff and you want to save a few dollars for a couple of those low current stuff, recommend measuring what their actual draw is, actual current draw is. But that's totally helpful, I think, to have a pack I don't have to care about so much dedicated to a low power device instead of consuming, one of my nicer, higher capacity packs. See ya.